Now let us have another problem where we have polar curves, and suppose that you want to find area under two polar curves. Okay, so how to find area under two polar curves? Suppose what the problem is like this. Okay, find area inside the circle r is equal to a sine theta, and outside the circle, okay, outside the cardioid, r is equal to a inside bracket 1 minus cos theta. So this occur already we have seen, it is cardioid. Okay, if it is plus, it is rightward face cardioid. Okay, so what I am talking about, this cardioid. So this is your initial line, a line perpendicular to initial line, that is theta equal to pi by 2 line. And what I am talking about, this cardioid. So what r is equal to a inside bracket 1 plus cos theta, it is a rightward face cardioid. Okay, but we have what, minus sign. As we have minus sign, it will be a what, leftward face cardioid. So leftward face cardioid. So first is what, a leftward face cardioid. So r is equal to 1 minus, r is equal to a inside bracket 1 minus cos theta is a leftward face cardioid. Now the second is a circle. Okay, r is equal to a sin theta. Note that r is equal to a sin theta is a circle. Just now we have talked about, it is circle on y axis having center. Okay, having center on y axis. Okay, and center is what, a by 2 0 as far as Cartesian uh, point is concerned, Cartesian center is concerned. So it is a by 2 0 and radius equal to a by 2. Okay, and if you have in minus sign, what, the circle will be here. Okay, so you will be having a circle on which axis, on negative y axis. If it is cos theta, it will be on positive x axis. If it is minus cos theta, it is on negative. Okay, and if coefficient is a, radius is a by 2. If it is 2a, radius is a. If it is a by 2, radius is a by 4. Okay, so coefficient here is what, coefficient of sine theta by 2 or cos theta by is very important over here. It is representing your circle divided by 2, or sorry, radius divided by 2. So if it is a by 2 is radius, and center equal to a by 2 0, here it will be 0 a by 2 because it is on which axis, y axis. So the second one is a circle, okay, having what, a radius equal to a by 2. So let me have direct a circle. So circle will be of radius a by 2, which is here. Okay, and yes, you will find that luckily what, these two curves are equal to a sin theta and r is equal to inside bracket 1 minus cos theta, they are what, intersecting with each other. So how to find out where they are intersecting? Solve them simultaneously. So you can check it out here what it is explained. Okay, so r is equal to a sin theta and r is equal to a inside bracket 1 minus cos theta. If you solve that, so put r is equal to a sin theta here, we get a sin theta is equal to a inside bracket 1 minus cos theta. A get cancelled, we get sin theta equal to 1 minus cos theta. Okay, then you will find that if I use here half angle formulae, sin theta is a 2 sin theta by 2 cos theta by 2, and 1 minus cos theta is 2 sin square theta by 2. Yes, 2 will get cancelled, so this 2 will get cancelled with this 2, 1 sin will get cancelled, and what remains, cos here, and here what remains, sin. So you will find that what, sin theta by 2 divided by cos theta by 2 is equal to 1, that is theta is equal to theta by 2 is equal to tan inverse of 1, and that is equal to pi by 4, and pi by 4 multiply by 2, that becomes pi by 2. So here we found that the value of theta is pi by 2. What is meaning of that? The cardioid and circle are meeting each other at theta equal to pi by 2. That is geometrical meaning of this. Okay, so you can observe the figure. So figure is like this. So this is the cardioid. Okay, so let me have another once again. So first one is this cardioid. So this is what your leftward face cardioid. Okay, so r is equal to a inside bracket 1 minus cos theta, so it is here. And second one is a circle. What is second one? second one is equal to a circle given by what, r is equal to a sin theta, and note that r equal to a sin theta and they are meeting at what, pi by 2. Okay, so theta equal to pi by 2. So what I'm going to do now, I'm going to shade the region inside yellow. Okay, inside the circle, outside the cardioid. So inside the circle, outside the cardioid. So inside means, yes, I'm going to have arrows inside. Okay, so let me have arrows like this. So inside the circle. Okay, and so this is what inside the circle case. And what about outside the cardioid? So outside the cardioid means what I have, what these will be the lines. So you will observe that, okay, so common region is this region, the region denoted by r. Let me clear out all this. So this is the region, and now what I want limit, for that I'm going to take a strip. So this strip, okay, this is the arbitrary position of the strip. It is a radial strip because all the curves are here polar curves, and this radial strip will rotate now from theta equal to 0 up to theta is equal to pi by 2. So from theta equal to 0 to theta equal to pi by 2. While its motion, you will find that the inner end of the circle will be on the cardioid, r is equal to inside bracket 1 minus cos theta, whereas outer end of the circle will be on r is equal to a sin theta. So what we observe, so theta varies from 0 to pi by 2. Okay, so let me put here, so theta varies here, theta varies here from 0 to pi by 2. Okay, while its rotation, yes, r value. So how to see the r values? Look at the inner end and outer end. Where is the inner end? So inner end is on this cardioid. So inner end is on the cardioid. This is your cardioid. Okay, so inner end is on cardioid, whereas outer end, where is outer end? Outer end is on what, your circle. So a inside the bracket, a inside the bracket 1 minus cos theta, 1 minus cos theta. Okay, and where is the outer end? So outer end is on what, a is equal to a, r is equal to a sin theta. So here q is, suppose that it is theta, therefore limit will be from 0 to pi by 2 and a into 1 minus cos theta to a sin theta. Now what is integrand? Integrand is actually dx dy, and what is dx dy in terms of polar? It is r dr d theta. So r dr d theta is your integrand. First integration is with respect to r, therefore what, theta will be outside. So theta is outside inner integration, but it is in outside, but it is inside outer integration. So what we get? We get integration of r dr only, and integration of r dr is r square by 2. Put upper limit, lower limit, and what we can simplify further part. Let us have another example. Find area between r is equal to 3a cos theta and r is equal to a inside the bracket 1 plus cos theta. Note that 1 plus cos theta is a rightward phase cardioid. Okay, so let me have first of your initial line, okay, then theta equal to 90 degree. Now what is first curve? So first curve is r is equal to a inside bracket 1 plus cos theta. Yes, it is a rightward phase cardioid. So it is a rightward phase cardioid. So it is a rightward phase cardioid like this. Okay, note that if theta is 0, r is equal to 2a. So note that this is what, theta is equal to 0, what, r is equal to 2a. So r is equal to 2a and theta is equal to 0 degree. Okay, now what next? Yes, this length is 2a. What is meaning of that? This length is, so this length is 2a. Okay, why I am recognizing this length 2a? Because I had to adjust what accordingly, what will be 3a divided by 2. Now look at the second curve. What is second curve? So second curve is a circle. Why it is circle? r is equal to some constant cos theta will be a circle of radius constant divided by 2. Constant is here 3a. So what is circle here? Circle is a circle with the radius 3a divided by 2. Okay, and center will be on what your, okay, so 3a by 2 means 1.5, so 1.5 somewhere here. So you will be having a bigger circle like this. Okay, so you have a circle and what it will be shown in the figure. So you will be having point of intersection even. So if you solve these two equations, r is equal to 3 cos theta and r is equal to a inside bracket 1 plus cos theta, yes, what a will get cancelled and you will be getting 1 plus cos theta is equal to cos theta. So cos theta can be taken on one side, therefore 2 cos theta is equal to 1 theta is equal to cos inverse of 1 by 2, and that is equal to what, pi by 6, that is pi by it is 60 degree, that is pi by 3. Okay, so we have bigger circle like this. So we have bigger circle like this. Okay, let me clear out first. Okay, and the point of intersection is, so what is the problem? Outside the cardioid, inside the circle. So outside the cardioid means outside the cardioid, we should not consider the inside part of cardioid, and inside the circle, so we should not consider outside part of circle. Okay, so what, this will be the common region. Actually this whole region is a common. Okay, therefore first what I will do, I will consider this part only, and if I multiply this region by 2, I will be getting the required area. So shall I here write the required area is equal to what, 2 times double integration over the region r. And what is limit of double integration? Now let me take a radial strip. Okay, this radial strip will move from what, theta equal to 0 up to theta is equal to what, pi by 3. Okay, so theta equal to 0 to pi by 3. While its motion, you can check it out, the inner end of the strip is on cardioid, r is equal to inside bracket 1 plus cos theta, whereas outer end of the strip will be throughout on r is equal to inside bracket r is equal to 3a cos theta, that is circle. Okay, so with that what your limit will be, so this is the strip, so limit will be from 0 to pi by 3, so 2 times 0 to pi by 3, this should be pi by 3, so 0 to pi by 3, 0 to pi by 3, and a inside bracket 1 plus cos theta to 3a cos theta r dr d theta. And what we can evaluate this integration very easily, as we have seen the previous method.